for this session, Mr. Anil Degre, who is connected live with us from Bengaluru, India. He is an electrical engineer from IIT Bombay. He is software architect, coach, and mentor. Sir is seasoned consultant software architect with a passion for making an project that involve requirement analysis, solution.
Sir, we cannot hear you. Sir, we cannot hear you. त्यांचा आवाज येईना. त्यांचा आवाज येईना येतं. नाही नाही ते बरोबर आहे. ते बरोबर आहे. Sir, you can continue.
Okay, good. Can you hear me now?
Okay. Okay.
Good afternoon, everyone, and welcome to this session. I'm going to talk about cloud computing and what a paradigm shift it has become. Right. So I'm aware that you already had one session on cloud computing in the morning. I'll try to make sure that I don't repeat some of the stuff, but fundamentally now cloud computing has become such an important aspect that I think it is okay on a conference like this to have two sessions on cloud computing. So today I'm going to talk briefly about what cloud computing is all about and why it has become such a big thing in our today's technology. Why we call it a paradigm shift, that is such a major change in technology over the last few years that it has completely changed the world of computing, upside down. And a couple of topics I will specifically focus on in this session is on startups and how cloud computing has really changed the world of startups, and it is one of the factors which has actually made startups really successful. As you are aware, now in India there are lots of startups, and many of them have turned unicorns. So what is it in cloud computing that helped startups to turn into unicorns or highly successful? And lastly, then I will talk a little bit about you as a student. I mean, addressing a little bit to the students of your college who are in the first, second, or third year, and what they need to do to be successful in today's world, right? So let's begin, right? And to begin with, let me spend some time on trying to demystify cloud computing. I mean, there are a lot of myths about it, but what exactly is cloud computing, right? And so, in simple terms, cloud computing, it has nothing to do with cloud really. And I don't know why the term cloud came, but it has stuck. Really speaking, cloud computing is nothing but computing which is taken on rent. All right. So just like, when you go to a new city and you don't have a car, you just rent a car for a day or two, or you live in a hotel, or, people coming new to a city rent a house, or sometimes people rent clothes for an event and things of that sort. So people don't buy something and rent it out simply because they may need it only for short term. And cloud computing is simply rental computing, where companies who don't want to invest money in computers or servers or a data center, or they don't have the capacity to spend so much of money, just take some computers or servers or a data center on rent for a limited period of time, let's say a month or two. That is what cloud computing is all about. And all these cloud companies we hear about, Microsoft, Google, Amazon, and there are many more. And even in India now, companies like Reliance, Airtel, etc., are getting into this business of creating data centers or renting their cloud. So they invest money in these data centers, and people like you and me, individuals or small companies, startups, or even big companies who don't want to spend their money on data centers, rent it from them. And that is what cloud computing is all about. It's very simple, right? It could have been called remote computing or rental computing, but for some reason that's not so exciting. Instead, uh, people call it cloud computing, and that term has stuck. So just remember, cloud computing is nothing but computers taken on rent, right? And it's not really in cloud. So that's another myth. People say, oh, is it somewhere? It's very much on earth. It's very much on ground, on some data center, right? And in fact, uh, companies, when they set up these data centers for rent, they try to distribute it all over India or all over the world, so that people living in a particular city would like to rent computers within that city, or users who want to use that data center find it faster when they are interacting with a data center within that city. So to that extent, cloud computing is not on cloud, it is on earth, it's there everywhere, right? And there are these data centers nowadays in all big cities, or sometimes even in remote areas. So wherever companies find there is demand, or wherever they find that rent is cheaper, or real estate is cheaper, or let's say electricity is cheaper, that is where they set up these cloud computing centers, right? And fundamentally, the data center in a cloud is very much similar to the data center in any company or any big corporate or university or college. In your college you might have a data center where there are computers, there are servers, and there are printers, and UPS and so on. So your data center, which is called on premises, is not very different from a data center in cloud, right? So a cloud data center, if you want to understand what a cloud data center is, just look at your own college's data center. And of course, the cloud data center is bigger, but and it may have more equipment, but the data center is the same. In a data center, you'll have computers, you'll have storage equipment, you'll have networking cables, wires, right? A UPS, fans, or cooling equipment. That's what a data center is all about. So that's what a cloud computing data center is. And so the fundamental difference is you either you either buy hardware or you rent it out. So if you buy hardware and set up your own data center, that is called on premises or dedicated or your own data center, right? So big companies traditionally used to create their own data centers using their own hardware, right? And their own administrators and things like that. But of late, they prefer to rent it out, right? And they find it better to rent it out rather than buying hardware. So even big companies are going to cloud now, right? It's not just small companies or startups who cannot afford to set up their own data center who are going to cloud. Even big companies who very much have the money and the power and the technology or the know-how to set up their own data centers are also preferring to use cloud instead of their own data center. Why is that? So we'll see that as to why are companies moving to cloud and why is cloud becoming such a big success story. Right? So fundamentally, it's all about satisfying some needs, and cloud actually satisfies a lot of needs of companies. Right? One fundamental need is cost. So what happens is when you are going to cloud, since it's rented, you don't have to spend crores and crores of rupees on your data center. So the upfront investment is very low. You are just paying on a daily basis or a weekly basis or on a monthly basis based on how much you use. So if your usage is low, you pay less. If your usage is more, you pay more. So that is how it is. So in that sense, companies have low upfront investment, and many companies find that a good thing because their money doesn't get tied up in a data center buying equipment or hiring very expert manpower for running their own data center. So it saves cost. That's the first big advantage for companies to move to cloud, right? Of course, over a period of time, companies end up spending money in terms of rental of the equipment, but they can at any point of time, if they realize that their needs are not so high, they can stop that investment. They can stop the rent, and that way, the risk is low. Okay. The other big advantage of cloud is its availability. So sometimes you hear things like data center went down or some service went down. So usually with cloud that doesn't happen because these cloud companies are really expert at running their data centers 24 by 7. So always their data centers will be available, and they take special care of it in terms of having redundant power supply, redundant network connections, redundant cooling equipment, redundant servers, and things like that. Also, these data centers are available everywhere. So in the sense that, let's say you start some business and most of your customers are, say, in North India, then you can rent up some data center in North India. And then let's say you want to grow to western part or southern part, then you can take up the data center in western or southern. Or let's say tomorrow you want to export and your products are being used more in Europe or US, then you can rent up these data centers anywhere. So the availability anytime and everywhere is a big advantage of cloud. So as your business grows or your requirement grows, you can quickly take up more capacity. And especially for companies in India, going somewhere outside the country and setting up a data center over there is very difficult. So they find it much easier to use cloud. And the third major advantage of cloud is the speed with which you can ramp up or ramp down your compute power. So suddenly, let's say many companies they start some business, let's say e-commerce or something like that, and initially they may have very few customers, so they can start with a few servers. As their business grows, they can quickly increase the servers, or let's say the business goes down, they can ramp it down. So the ability to at at a click of a button ramp up or ramp down your your data center capacity, both in terms of servers, CPU, the memory, right, and things of that sort. So that agility, it's also called agile data center. So cloud data centers are agile, and that's a good thing which companies like. I mean, think of the olden days when you had to buy a server. You have to raise a tender. You'll get quotations, then you choose a vendor, then you give an order, and then you get your delivery after a few weeks, and then you have to set up time. It can easily take 2 to 3 months for you to set up some additional capacity in a traditional way. But with cloud, in a matter of hours, you can increase the capacity in your data center. So the speed is a very good advantage of cloud, right? And another very important advantage with cloud companies have set up, especially the well-reputed companies, is the reliability of cloud. So the cloud is always available. It handles search traffic. So what happens is, I mean, recently we saw cases where, for instance, income tax site, when suddenly in July a lot of people try to file income tax, then there is search traffic, then a well-designed cloud will be able to take it. Or CET admissions or these kind of sites, what happens is on the day when students have to put in their say choices for colleges, suddenly there is search traffic. Or let's say there is a result of SSC or HSC, suddenly there is search traffic. So all companies face search traffics. Let's say e-commerce companies face search traffic at the time of holidays and things like that. So a reliable cloud data center is one which can handle this search traffic, or even if there is a failure, it's able to recover quickly, right? So all these positive aspects of cloud is what prompting companies to move to cloud. And specifically coming to startups, now India is now being is known as a country of startups, and we have so many startups, and lot of them became very very successful, and became unicorns, with valuation more than $1 billion in a matter of few months or few 1 or 2 years. So how did that happen? And my contention is that this is something which has happened only recently. I mean, even 10 or 15 years ago, we never heard so many startups became so successful. Or even if they did, they were in foreign countries. But in India, we didn't have so many startups which became successful. And that's something which has happened of late. I would say a large part of their success. Now, of course, there's a lot of encouragement from the government and things of that sort. But a part of the reason is the availability of cloud has really helped startups to become successful, right? So startups, cloud has been a big boon to all startups, because all of the advantage of cloud that I said, that low upfront cost, or low investment, and the ability to quickly handle surges, and the availability of cloud all over the world, is especially beneficial to startups. So to all startups, cloud has been a big boon. So today, if you see any startup, literally 100% of all startups are on cloud. No startup will spend time or spend money on setting up their own data center. They don't need to do it. Right? And it also reduces their technology gap with large corporates. So large corporates obviously are able to spend money on their own data centers. And I'm not saying no one has their own data centers. Yes, a lot of companies still do have their own data centers, but only big companies are able to do so because they have the money, they have the power, they have the ability to hire, you know, manpower and things of that sort. And if startups did not have the ability to rent or use cloud, would be a huge gap between startups and large corporates, and always the large corporates would succeed in the market. But because now startups have this advantage of cloud, even a small startup with 30 or 40 employees is able to compete with a large corporate with thousands of employees. Why? Because the technology gap has reduced. If a startup has an idea, they can rent a cloud, and on cloud they will get all the latest equipment, let's say some complex AI technology or a GPU or any technology that you want is available in cloud. It would be as good as, or maybe even better than what a large corporate can set up in their own data center. Okay. So that's a huge boon to startups. Cloud has become a huge boon to startups. Also, because of this, startups are able to bring ideas to market faster. I mean, in general, startups always have a lot of ideas, and they are very innovative because it's a small company. Their big problem in the past was they had good ideas, but they didn't know how to deliver it or bring to market faster. But now with cloud, startups, even a small team of 5 or 10 people can come up with a brilliant idea, quickly implement it on cloud and bring it to market. So that has been a huge boon to startups, reducing technology gap, bringing ideas to market faster. And also startups can quickly change their plans. If let's say the market changes, or let's say they realize that whatever was their idea is not working out, then they can move to some other idea and they can quickly ramp down their previous you know um, servers on cloud and start up some new servers, which will be a slightly different setup, slightly different configuration and things like that. So startups are able to quickly start, quickly come down, quickly move, change plans in response to market changes. Or let's say they realize their market, initially they thought the market is more in Europe. Now, let's say they realize no, it's more in Asia or more Latin America. They can quickly change their plans. It has made startups very, very agile. And so that's the impact of cloud on startups. Okay. And so now let's say you as a student, or starting your career in the computing industry, you are like, okay, it's good, great, but what is there in it for me, or how should I adapt to myself, right? Somebody asked the question, what skills are required to be successful in cloud? So this my last slide is for all of you students, how you can be ready for cloud, right? So first of all, try to understand what is meant by cloud native design principles, right? So in our traditional computer science, we used to teach things like data centers, algorithms, programming, discrete math and things of that sort. Now all those things are important, but there's also a new field of study called how to design your application or any product to be cloud native. And what is meant by cloud native is it is designed right from the beginning to be run from cloud, right? So there are certain cloud native design principles. Now, of course, we don't have. I mean, this time is too short for me to get into those. But you can get a lot of literature on this online. So try and understand cloud native design principles, and that's your first step to be ready for cloud, right? So you need to be aware of what these design principles are, because more and more what you do in real life is going to be on cloud. So you need to be well steeped in these design principles for cloud native application, right? The other thing I would say is always think global, right? So let's not be limited by where we are living. We are living in India, or this is our environment and this is what it is. But more and more we are citizens of the world, especially people working in IT industry or computer industry are not limited by your present location. You can work for any company anywhere, and think global. Be aware of what is happening everywhere in the world. Be aware of global challenges, right? And especially cloud allows you to deploy something in any data center anywhere. So think global in all your in all your thoughts. And paradoxically, you also need to think local, in the sense there are still a lot of India specific or our own geography specific things which maybe global companies are not able to come up with. And that's why some of their products or some of their technologies or some of their apps people are not able to use in our country very effectively. And what you can do is pick some ideas from some global app which has been successful, but come up with your own local version of it, which is kind of tuned to the requirements of our own country. And if you think like that, then that's another track where you can be successful. So think global and think local. So if you think on both of these aspects, right, and that's going to be good for you. Lastly, expect these kind of technology shifts to happen in your career. I mean, today you're learning about cloud. 10 years ago, if you think of people who graduated, they hadn't heard about cloud and they don't know what is cloud computing, right? But does it mean they are not fit to be in cloud or working on cloud? Not really. They didn't learn about cloud when they graduated, but they had to learn anyway after graduation. So like that, in 2033 or 2043 or 2053, which is going to be your career, right? What technology will come, or what new changes will come, or what paradigm shifts will happen, we do not know. All that we know is, yes, there will be such paradigm shifts every 5 or 10 years, and you need to be ready for it. So uh, you don't know what it is going to be, but one thing we know for sure is there are going to be more technology shifts in your career, and mentally you need to be prepared, right? And always be prepared to learn and be a student throughout your career. And that's a given. It's going to be an interesting and exciting journey for all of you graduating in the coming year or two. So I wish you all the success in your career. And so thank you. I want to thank the DHB Sony College for giving me this opportunity to talk to you, all of you, specifically to Dr. Vasanti Iyer for giving me this opportunity to talk. Thanks.
Mr. Anil Devkar sir, for sharing
Yeah.
your valuable time. Your words have resonated with us, and we are leaving here today with a valuable knowledge and a fresh perspective. Your presence has made a significant impact on all of us, and we are genuinely thankful for that. Thank you, sir.
Thanks.
Welcome back, sir. Welcome back, sir. Hello, everyone. I am Neha Kulkarni from BCA third year. Now, I would like to invite Mr. Pratik Gurudatta, sir, who is connected live with us. Sir is an accomplished professional with expertise in full stack engineering, microservices, micro front end, secure web application, and DevOps. Sir currently holds the position of Associate Director at Union Bank of Switzerland in Warsaw, where he specialized in JavaScript, Microsoft Azure, GitLab, Azure Kubernetes, Services, AKS, Kubernetes, TypeScript, and full stack development. Prior to this role, he served as a senior software engineer at Mindtree, Poland, contributing to both front-end and back-end developments, as well as DevOps practices. Sir earned his BSc in Computer System and Network from Warsaw University of Technology and has a strong research background, notably in robotics. Sir has presented lectures on IoT and ESP32 and has worked on projects involving asset tracking, autonomous driving assistance system, and custom CRM software. Sir diverse skill set also includes in experience as a software engineer at Seekings Company, where he worked on IoT hardware and data visualization platforms. Additionally, he has conducted research on late robotics at Robotics Research Institute of Computer Science at Warsaw University of Technology. Such dedication and innovation has earned him prestigious awards, including Super 4 National Level Awards from IEEE, the Challenge of the Prime Minister of Poland. You can learn more about him on his website at pratikgurudatta.xyz or contact him via email at pratikgurudatta@gmail.com. Sir, continue your session.
Thank you so much for that introduction. It was very generous of you. Hello, everybody. Thank you so much for having me here, and thank you, Dr. Vasanti Iyer, for inviting me. It's an absolute privilege to be talking at Sony College. Could I get a confirmation if my presentation screen is visible?
Yes, sir. Okay.
Right. Thank you so much. So, this presentation that I would be giving about is a research project that was conducted at the Warsaw University of Technology, along with my professor, Dr. Maxim Figat, and myself. So this project was something that started in my dorm room a couple of years ago, and it took off as a full-fledged research project. And this is the thesis that I defended. And the results that came out were quite vibrant and was quite exciting for me. One of the aims that we had is to build a robotic system, a platform where users could also download the source code as well as the project materials and 3D designs and print the robot themselves and also work on it. There are various institutions like Boston Dynamics, ETH Zurich, who've made very profound walking robotic systems. And my aim, or my humble aim, was to develop a system that was quite similar, but these are the small steps that we took in that direction. So the title of our project was Motion Synthesis of Quadrupedal Robots for Optimized Gaits and Body Balance. So as the title says, we wanted to build a system, which is a walking system, and we wanted to build a full stack solution for it, starting from the software, the firmware, the design, as well as the hardware and electronics. It was a complete end-to-end design that we worked on. So typically over the last couple of years, and at least in the last decade or so, there's been a gradient of changes in robotics. So initially it was very simple mechanical devices that were there. And then a couple of years later, we had mechatronic systems such as industrial arms and surgical robots. So these had precise control, but it lacked intelligence. It lacked intelligent control. It always needed a human operator to drive that precision forward. But that precision was engineered by extremely good, reliable, and scalable software. And the trend that we're seeing in the last, let's say, 5 to 6 years in intelligent systems is the introduction of machine learning with robotics, which replaces the human operator to drive the robot itself. So we have examples like Tesla, Boston Dynamics, and Animal. Animal is this robot that is made by ET at Zurich. This isn't the robot that we worked on, but this is a very prestigious robotics platform that was made by ET at Zurich University. So these are some of the profound examples of how intelligence has replaced human operators to drive these robots. So coming to our project was to build such a four-leg walking system. The robot was supposed to be able to balance on four legs. We had an intention to develop a mathematical model for the robot such that anybody could work on this mathematical model and implement it on a real hardware robot. As long as the configuration of the robot is correct, as long as the number of legs is four, you could vary the length, the radius, and the size of the robot, and our mathematical model would still work for this. We also had an intention of developing the center of gravity estimation for the robot. So what I mean by this is we needed a system to make sure that the robot could balance on its four legs and it could do complex movements without falling over. And this is called as the center of mass estimation. And once we had the ability for the robot to stand on its legs and maintain stability and balance, the next step is to develop trajectories for the robot to be able to walk, and optimal trajectories for the robot to be efficient at walking or moving or doing any sort of movement. And one of the goals we had was to make it a full stack project where we work on it end to end. So there's the ownership of this would be completely ours. Now, apart from the project goals, we had a couple of theoretical goals that we had to reach in order to make this work. So we built a couple of mathematical models, and these are analytical models, and each analytical model would cascade into another model. And the end result is something that was quite exciting what we made. So in the nomenclature of robotics, we had something called as the forward kinematics model, which is a sort of a model where you input the joint space, such as the angles, and the output would be scalar Cartesian coordinates. I'll explain what this means through a small demonstration. And we needed something called as the inverse kinematics for every leg. Now, when you combine the inverse kinematics of four different legs, you get something called as the body kinematics. Now, this is very synonymous to how humans walk. Now, you have two legs, and both of these legs combine to the torso makes the human body move. And in a similar fashion, we needed four inverse kinematics model for four legs for the body to move. The next step is to generate the center of gravity computation model, which will basically allow us to dynamically understand where the center of gravity of the robot is when it walks and moves around. The next step we had was it's called as the gate generation or the step sequencing model. Now, gate is something that is, in other terms, it's called as the style of walking. So all four-legged animals have very different styles of walking: cheetahs, tigers, leopards, horses, dogs, and cats. And when you change the style of walking, you get very different outcomes in the efficiency of walking as well. So cheetahs basically run extremely fast because of their style in which the size of the step, the height of the step is very different from that of a horse. The last step is something called as the trajectory generation from nth order Bezier curves. So we create these specific curves in 3D space so that the leg or the step of the robot would follow these curves. And the more optimized curves you make, the more faster and more efficient the robot moves. So to give you an understanding of what forward kinematics is, here we have this representation here. So you can see that, okay, so we assume that this is one leg of the robot and it's trying to reach a point in space. That's the blue dot. Now, as it tries to reach this point in space, you see that it's doing a lot of trial and error. It's trying to get to its point with a lot of time. The convergence of the solution is extremely slow, and it isn't a dynamic system. So when you want to do precise, repeatable motion, forward kinematics isn't going to work. So the way it works is you have to tune the angles of every joint to make it reach a particular point in space. But in the real world, if you want to make this happen, what you have to do is you have to provide the point in space, and the arm or the leg would figure out how to move its individual joints. Now, this simulation on the top right here shows that the robot is moving along a single path. Now, what I've done here is I've just defined the path, and the piece of leg is trying to figure out its angles by itself, or the mathematical model is trying to do it. The best outcome of such a system is that you're producing extremely continuous, extremely harmonic, and dynamic movement. So now that it can follow a straight line, any sort of computer algorithm can generate complex shapes in three-dimensional space, and you can make it follow as within that defined space. So once we have the inverse kinematics for a single leg, we create something called as the body kinematics. Now, body kinematics will provide the ability to control the end effectors by defining the body kinematics and body trajectory. So to put it into simple terms, what this means is when you move of the end effector, we
accomplishments of its model, the body is model that we was again quite now
live. So I'll not take much of your time. I know you had a long day today. So our topic, that is sustainable future, right? How technology will play an important role and a kind of contribution towards sustainable future. So before proceeding further, I would like to thank the institute and the management for providing me this opportunity to be a part of this interaction and this session, where we are actually going to explore about what is the role of technology in education, how education can be elevated and transformed using technology. In the next 15 to 20 minutes, we are going to explore that. And as I said, I request all the participants and the audience to make the session more interactive. Don't hesitate to, if you have any inputs to share, or if you want to, interrupt me and ask anything. Alright? So, what do you understand by sustainable future? Have you tried, understanding what does this term mean? Sustainable future. Yes? Any participant? Sustainable future. आपने टॉपिक का नाम तो पढ़ा होगा, ब्रोशर जो आपको मिला था, तो आफ्टर दैट यू माइट हैव थॉट कि सस्टेनेबल फ्यूचर का मतलब क्या होता है. तो गूगल पे कोई जो ट्रांसलेट करे तो उसको पता चलेगा कि टिकाऊ भविष्य, राइट? आई गेस समवन इज ट्राइंग टू गूगल और सर्च, राइट? So we need to understand the future where we are creating less waste, the future where we are heading towards circular economy, right? The previous speaker, he was talking, very interesting topic with regards to robotics, with regards to automation, with regards to kinematics, right? With regards to swarm robotics, right? He was repeatedly using this word swarm, right? Swarm robotics या swarm technology का मतलब ही यही है कि अलग-अलग रोबोट्स इस तरह से कंट्रीब्यूट करके एक टास्क और एक चीज को परफॉर्म कर सकते हैं, राइट? So I was expecting that you people, will take a notes when he was talking in a very interesting way with a proper flow about the technological development and the transformation that is happening. All right? So here, with regards to sustainable technology or sustainable future, if you understand more, right, you will be able to get the essence of this topic. You bring any technology, you take any developed country, you take any country, wherever the technology is playing a key role, the best way to penetrate any technology is through education. अगर आप टेक्नोलॉजी को एजुकेशन सिस्टम के थ्रू पेनिट्रेट कर रहे हैं, ले आ रहे हैं, then you will be able to see the mega impact. Because these students, those who are learning today, are going to be the leaders tomorrow, right? So if they are able to understand the right direction, right application of technology, they will be able to create an impact. How the previous speaker, being from India, he was creating an impact in Poland, right? So we need to understand this part, and I am very fortunate for this opportunity today. So as I said, Ashar this side, I got an opportunity to work in multiple roles, multiple domains, starting from my mechatronics engineering when I did my bachelor's. Then I did MBA in innovation and entrepreneurship. I guess many of you have not heard about this stream or this term, MBA in innovation and entrepreneurship. Apart from that, mechatronics, I don't know how many of you have heard about BTech in mechatronics. So these were the things that actually led me to explore the multidisciplinary approach, where multidisciplines and various other branches, sectors are parallelly working together and forming a solution or creating an impact. So during these years, I got an opportunity to interact with several stakeholders from technology, from industry, from academia, and from education background. So in that, what I learned or what I experienced or what I felt was, as I said earlier, technology, to penetrate any technology, to bring any new technology, education is the best way to penetrate any technology. And now we need to see how we are involving and how we are integrating education, right, with the today's technological environment. So when we talk about technology, right, we have lot of things to explore, right? In today's time, we talk about big data, right? We talk about big data, we talk about machine learning, we talk about AI, we talk about data science, we talk about cloud, we talk about cyber security, right? Different dots are there. Different themes are there, different sectors are there. Now, it's upon us how we are, absorbing these different fields, being a student, being a teacher, right? And integrating or applying those things into our learning phase. So that is what we are going to focus, how technology is transforming education. How technology is transforming education. So I'll ask you a simple question, right? I'll ask you a simple question and I'm expecting that you people will definitely give a response to it. See, in order to explore the use of technology, the first thing that is required is thinking out of the box. So, आप सोच रहे होंगे कि thinking out of the box का मतलब क्या है, right? Thinking out of the box का मतलब क्या है? So, we'll take a simple example. Let's suppose I'm standing here. So when I'm moving from this point to, let's suppose, this stair point, right? So I cover, yes, distance, exactly. What's your good name? Okay, so I covered a distance, right? Now let's suppose this quantity distance